Okay, hello guys. So in this lesson we're going to learn how to add and subtract rational expressions. Now what's a rational expression? A rational expression is an expression in which the variable appears at the denominator. So for example, let me show you some example of rational expression. We may have 2 over x is an example of rational expression. We have a fraction in which the variable x appears in the denominator. Another example may be 1 over y minus 1. It's a rational expression. We may have 2z squared plus 1 divided by z to the power of 5 minus 3. So in this case the variable appears both at the numerator and denominator. But as long as the variable appears at the denominator, this is a rational expression. So the goal for today is to be able to add and subtract rational expressions with a common denominator, and also when the denominator is different. Now it's much more simple to add and subtract a rational expression with common denominator because you can just combine numerator, but it becomes more complicated when the denominators are different, because in that case we need to find the least common denominator. So as a quick review, let's recall how to add and subtract fractions when we just deal with numbers. So for example, how do we subtract 1/2 with 1/3, right? Well, if the denominator is different, then we need to rewrite these two fractions in such a way that the denominators are going to be the same. So the common denominator is 6 in this case. So what you want to do is you multiply and divide this fraction, the 1/2 by 3, so we get the denominator of 6. And here, to go from 3 to 6, we need to multiply and divide by 2. We are not changing the value of this fraction, because 3 divided by 3 is 1 and 2 divided by 2 is 1, but we are rewriting this so that we can combine the two numerators. Alright, so in this point what we do is 1 times 3 is 3, 2 times 3 becomes 6, and then 1/3 becomes now 2 divided by 6. And at this point, since the denominator are the same, we can just combine the two numerators. In this case we are going to subtract the two numerators, so we know that 3 minus 2 is equal 1, so we end up with 1 over 6. So this same process can be used with rational expression. Now let's start by adding and subtracting rational expression with common denominator. Okay, so here is the first example number 1. And as always, I invite you to try to work this problem by yourself before I show you how to work them out. Okay, and then check with me what you're doing. So here we have a u minus v divided by 8v, and we want to add up 6u minus 3v divided by 8v. So just to make sure that, I want to make sure you see that this is a 3v. So 3v. Alright, take a look at the denominators. The denominators are exactly the same. So the least common denominator is 8v in this case, right? So there is nothing you need to do to change those denominators. So we know we're going to end up with a denominator which is 8v. So the only thing we need to do is combine the two numerators, okay? And notice that we have a plus between the two fractions, which means that we need to add. So 1u plus 6u end up to be 7u. And then we have negative v minus 3v, so negative v plus minus 3v. It means it's like to say negative 1 plus negative 3, which is negative 4. So we end up with a negative 4v. And this expression cannot be simplified. So this is your final sum of the two rational expressions. Alright, so now try to work this problem by yourself. So we have m minus 3n divided by 6m cubed n, and then we are going to subtract in this case m plus 3n divided by 6 m cube n. Alright, so try to work this by yourself and then check with me. Okay, so I hope at this point you did this by yourself. Notice how the two denominators again are the same, so the least common denominator stays 6m cube n. So the only thing we need to do is combine the two numerators. Notice that there is a negative sign in this case, so we need to subtract. So we're going to start by subtracting this m with this m, so m minus m practically cancel out, becomes 0. And then be careful with this, we have a negative 3n, and there is a plus 3n here, but there is a negative. These two don't cancel out because of this negative sign. So let me make sure you see this negative sign here. So this negative sign makes this 3n, okay, this one, a negative 3n, right? Because negative 1 times positive 3n becomes negative 3n, right? So this part can be combined to negative 3n, right? So the m is going to cancel out, as we said. But now I have negative here in front of the fraction and plus 3n. So this quantity becomes a negative 3n. So negative 3n plus negative 3n becomes negative 6n. Negative 6n. And this is your final difference of the two rational expressions. I want you to notice that in this case you actually can simplify this rational expression, because we know that 6 and 6 will simplify to 1, right? So 6 divided by 6 is 1, and n divided by n, as long as n is different than 0, will simplify to 1. So we end up with a negative 1 at the numerator, and then we're going to divide this by m cubed at the denominator. So the simplified form will be negative 1 divided by m cubed. Okay? Okay, let me show you another example with common. So let's call this number 3 with a common denominator. So let's assume we want to adapt these two expressions that are x plus 2 divided by 2x squared plus 13x plus 20. And then we want to subtract this with x plus 3 divided by 2x squared plus 13x plus 20. Okay, so again, try to do this by yourself. So the denominator is the same, so it's gonna stay. So I have a 2x squared plus 13x plus 20. And now the numerators can be combined. We have an x plus 2 minus x plus 3. So if you want, I'm gonna combine this. I'm gonna do this a little bit different than the previous one, even though you can solve exactly as the previous one. Now you should see immediately x minus x becomes 0, and this becomes 2 minus 3, which is negative 1. But you can also rewrite the numerator as x plus 2, and then this negative is going to make x plus 3 all negative, right, because it's negative 1 times x and negative 1 times 3, so this becomes negative x minus 3, and then from here notice how the x will simplify to 0, and 2 minus 3 end up to be negative 1, so you end up with a negative 1 over 2x squared plus 13x plus 20. So you can write negative 1 over this. The negative can also be put in front of the fraction. Okay. All right. So now so hopefully it's clear how to add and subtract a rational expression with the same numerator. Because the only thing you need to do is combine the numerator. But things becomes a little bit more challenging when the numerators are not the same. Okay. So in this case, we need to find the least common denominator and then make sure that we find the common denominator for the two rational expressions. Alright, so this is number 4. So let's try to subtract these two rational expressions. 6 divided by x minus 1 minus 5x divided by 4. Well, we can find, so hopefully you notice that here the least common denominator, LCD, is most of the times when the two expressions are different, the LCD is the product of the two expressions, right? So in this case it would be 4 times x minus 1, because this quantity is divisible by x minus 1 and also divisible by 4. Okay? But your main goal should be, even though you don't know exactly how to find the LCD, which actually is found the same way you find with numbers, but the most important thing I want you to realize that in order to simplify, in order to combine these two rational expressions, that you want to have the same denominators. Okay? So try to make the denominators equal to each other. That's the main step. I think it's the key of simplifying a rational expression. Try to make the denominators equal to each other. So even though the denominators you are going to, once you make them equal to each other, even though that denominator is not the least common denominator, you will still be able to combine these two rational expressions. So more important than LCD is try to make the denominators equal to each other. So in this case, how are we going to make the denominators equal? Notice that the first denominator is an x minus 1 and the second one is a 4, but you want to make them equal, right? So what we can do is, well, there is an x minus 1 which is missing here, right? And there is a 4 which is missing in the first one. You can put it here on the right, you can put in front. Usually we put in front. Do you agree that these denominators are now the same? Okay. Now, of course, I cannot just do that, right? Add these terms to the denominator. If I added a 4, so more precisely, if I multiply x minus 1 by 4, well, then I need to multiply the numerator by 4, right? Otherwise, my fraction is going to change. Instead, this 4, we could simplify, we end up again with 6 divided by x minus 1. So I'm allowed to multiply and divide by 4, right? Because I'm not changing this rational expression. And the same here on the right hand side. I have a 5x divided by 4. If I decide to multiply the 4 by x minus 1, then there is a next one is 1 in the numerator I need to multiply by, because again these two in theory can simplify and I come back to 5x over 4. So I'm not changing the I'm not changing this rational expression. I'm not changing this difference. The difference stays the same because I multiply and divide each expression by the same term, which in theory could simplify, so we come back to the original one. So this is the key process. You want to make the denominators equal to each other by multiplying, divide by anything you need to. And then, once you do that, it becomes exactly like problem number 1, problem number 2, and problem number 3 I showed you earlier. Because the denominators are the same, so you can just combine the two numerators. So, now we have the same numerators, which is the same, denominator, which is 4 times x minus 1. So we can combine these so we can combine the two numerators, and so what I need to do is just multiply 6 by 4, which is 24, and then here I have a negative 5x times x minus 1. And at this point, just try to simplify this expression as much as you can. So the denominator is 4 times x minus 1. And now the numerator is 24 minus 5x times x, which is 5x squared, and negative 5x times negative 1, which is positive 5x. And we are done. Okay? We cannot simplify this further, so this is your final rational expression. Okay. Okay. Let's work some other problem. Okay, so at this point you should be able to work this problem on your own. Okay. Let's try. Let me see. Try to do this by yourself. So 3 divided by x plus 7 plus 4 divided by x minus 8, and then check with me, okay? Okay, so assume that you stop the video, that you try to work this problem by yourself, and now you can verify with me. Alright, so how are we gonna make the two denominators equal? Well, if you look at the first one, we only have x plus 7, so the x minus 8 is missing, right? So what we can do is multiply this by x minus 8, and multiply this by x plus 7. But if we do that, then I need to multiply this numerator by x minus 8, and this by x plus 7, right? Because I don't want to change the two fractions, but now the two denominators are the same. So we end up with a single common denominator, which is x plus 7 times x minus 8. If you want, you can multiply these two expressions. You can just keep them as x plus 7 times x minus 8. But now I'm allowed to combine the two numerators. So what we have is 3 times x minus 8 plus 4 times x plus 7. Okay? And now the denominator still stay the same, which is x plus 7 times x minus 8. And now I have 3 times x. I can use distributive property, so it becomes 3x minus 24 plus 4 times x, which is 4x, plus 4 times 7, which is 28. So let's combine this, and we get x plus 7 times x minus 8, and the numerator is now, well, I can combine this 3x with this positive 4x to 7x, and then finally we have a minus 24 plus 28, which is plus 4, and we're practically done. We cannot simplify this. So this is the final rational expression. Okay. So at this point I'm going to show you one last example, and then I'm going to make another video with additional problems. Okay, so let's work number 6. Okay, let me see. Okay, so let's start. I'm looking at some problems I have here with me. Okay, so let's try to work this problem. We have 2 divided by 3x squared plus 12x plus 8 divided by 2x. Okay, so 3 is squared plus 12x, and then we have 2x. Okay, so in theory what we can do is multiply and divide the first fraction by 2x, and then we can also multiply and divide the second rational expression by 3x squared plus 12x, and it's going to work. Okay, so at the end it may simplify, and it should work. But I want you to notice also something in this case. It's a little bit different than the previous problem, because notice how this x here in the second rational expression is already present here in a 3x squared and 12x, right? So the least common denominator is actually not the product of the two denominators in this case. Okay, so in order to notice that, anytime you can factor out a denominator, try to do that. Okay, so it can be convenient. So let's factor out this 3x squared plus 12x. So how are we going to factor out this? Well, notice that there is a common factor between 3x squared and 12x, which is 3x, and then if you open parentheses, you end up with x plus 4. So I'm going to rewrite this way, and then here I have 8 divided by 2x. Okay, so once I factor this, let's try to make the two denominators equal to each other. So what should I do for the first fraction? Okay, so what's missing in this denominator that I have instead here? I have a 2x, right? And notice how the 2 is missing here, right? There is no 2. But how about the x? Is the x missing? Well, the x is already here, right? The x is already here, so there is no need to multiply and divide by 2x, right? I'm trying to make the two denominators equal to each other, remember, right? So what I can do is just multiply and divide by 2. Okay, so multiply and divide this by 2, because 2 is missing here. What's missing instead of the second denominator? Well, the x plus 4 is missing and the 3 is missing, so we should multiply by 3, the x instead is already here, 3 times x plus 4 and divide by 3 times x plus 4. Now, if we decide to multiply and divide instead by 2x, it will not be incorrect, okay? But then we will end up here with an x squared, and I should multiply by an additional x here on the right hand side. So we can also work out the problem that way, okay? So, do I have the same denominator now? Well, let's see. Alright, so this becomes 2 times 2, which is 4, and then this 3x times 2 becomes 6x times x plus 4, and then I have a plus, well, this becomes 8 and 3 is 24 times x plus 4, and then the denominator is 2x times 3, which is 6x times x plus 4. So now the two denominators are the same, so I can rewrite this in terms of a single denominator, which is 6x times x plus 4. And I can combine the two numerators, so we have 4 plus 24 times x is 24x, and then 24 times 4 should be 96. Okay? Alright. So, looks like we are done. Notice that we can actually simplify this. Okay? So we can simplify this because 4 plus 96 can be combined into 100 plus 24x and then divide by 6x times x plus 4. And now, notice how we can divide everything by 2, right? 100 divided by 2 would be 50, 24 divided by 2 would be 12x, and then this 6x divided by 2 becomes 3x, and then x plus 4 is going to stay. So that's a simplified final rational expression. Okay? So hopefully all of this is clear to you. If you have any question, please let me know. And in the second part, I'm going to show you some additional problems. And then I remind you guys, make sure you always work the ALEKS assignments. Okay? Okay, I'll talk to you later.